generating function associated with the harmonic number of order p. So basically, harmonic number of order p, what does this mean? We know that harmonic number is basically the sum from n equals to 1 to k of 1 by n, yeah. And harmonic number of order p, written like this, means that sum from n equals to 1 to k of 1 by n to the power p, yeah. And if this, let's say, is infinity, in that case this is just Riemann zeta of p, yeah. Now if you have the idea about what harmonic number of order p is, let's try to find its generating function, yeah. And now for that we will basically just use the sum definition of this harmonic number of order p. You know that let's say sum from k equals to 1 to infinity. Now this is sum from n equals to 1 to k, yeah. And this is 1 by n to the power p x to the power k. Now let's say we want to change the order of the summation. Now for that what we can notice is basically k is going from 1 to infinity. Let's say there's a k, there's a n. K is going from 1 to infinity, yeah, in this direction. And for that n is just going from 1 to k. And okay, so basically if this will be the k line, n is just going from 1 to k, yeah. So this is the person we are summing up, yeah, that the sum covers. Now an alternative way to cover this sum would just be let n go from 1 to infinity, yeah, but the k goes from n to infinity, yeah. So this is basically n equals to k line, yeah. And earlier, like k was going from 1 to infinity and n was from 1 to k, yeah. And now n is going from 1 to infinity, but k goes from n to infinity, yeah. This is basically n and n to infinity, and we cover the same area. So k goes from n to infinity, yeah. That's the idea. We're interested in sum like that, and that does make things simpler. So like the ideas like introducing integrals and then swapping the integrals, or let's introducing sum and swapping the sums, such ideas like most of the time make things simpler, and that's a really beneficial tool. And that's what we are going to use over here. Sum from k equals to n to infinity. Now this is the same, x to the power k by n to the power k. We also need to care about the convergent issues, but that's fine over here. And now since this sum is in the world of k, 1 by n to the power is just p is just a constant. 1 to infinity, 1 by n to the power p is just a constant. Now sum this up. The first term, this is the geometric series with first term x to the power n and ratio x, 1 minus x. Now 1 by 1 minus x is just a constant, we can take that out, and you have sum from n equals to 1 to infinity of x to the power n by n to the power p. So that's why this is we know that this is just the definition of li base p of x. Now there's 1 minus x outside. That's why we got this answer. Yeah, that was nice. Now to talk about the flow of the solution, it's not even a solution, it's just 4 lines answer. Okay, anyways, we just see the definition of the h sub k to the power p. Basically this is notation, not really power. And then we swap the sums using this idea over here of covering the same area. This is basically the integrals, but here's also it's fine. And now after that because both are actually sums, integrals are sum, both are sum. And after that we just took the constant outside and sum this up using geometric series, and this was the definition of the LIP of x function, and that was it. We solved the problem. Hope you enjoyed the video. Thanks for watching, and look forward to seeing in the upcoming videos too. Yeah, and yeah, do consider like this sum to find, like let's say you can substitute x as 1 by 2 or other values, and you can get different answers. That was it.